In this video we are going to discuss about MOSFET bias. So there are two types of biasing. One is voltage divider biasing, which is also called as self biasing, and another one is dual supply. I have given VDD and VGG supply, and the second diagram I have given VDD and minus VSS. So these are the three biasing we are using for MOSFET. So based on that, we are going to discuss about one problem in order to find the value of the Q point. So first let me take dual supply method. Here I have given two power supply. One is to drain and another one is to source, 5 volt and minus 5 volt. RD value, RS value and RG value is given, okay, and Kn, that is nothing but beta n, that is equal to 5 milliamps per volt square, and Vt, threshold voltage, is equal to 0.8. So we know that in order to make the transistor to operate, MOSFET to operate in a operate as an amplifier, it has to be in the saturation mode. In the saturation mode, the value of IDS is equal to Kn divided by 2 VGS minus Vt the whole square. So I am going to substitute the Kn value. So if I substitute Kn value, that is 5 divided by 2 is 2.5 milli. So Vg I have given as 0. Okay, Vg is 0 since it is grounded. So Vg minus Vs is 0 minus Vs minus Vt is 0.8. This is what they have given. And next, from this equation I can write this is your Vs, right? This is your Vs. So Vs is equal to ISRS minus 5 volt. Okay, so Vs is equal to ISRS minus 5 volt. Is is nothing but Id. So Id I am going to substitute. Id is we don't know the value of Id. So Rs they have given 9.5 K. So this is another equation. Okay, this is your second equation, and this is your first equation for ID. So you are going to substitute this, substitute the second equation in the first equation. So if I substitute this equation, I'll get this, and I'm going to divide the whole term by 2.5 milli and apply A plus B the whole square formula. So you will get this. And you bring this 0.4k ID to the right hand side, you will get 90.25 mega ID square minus 80.2k ID plus 17.64 is equal to 0. So if you solve this quadratic equation, you will get the value of two values of ID. One is 0.4 milliamps and another one is 0.499 milliamps. Okay, so if I substitute this, if I take ID is equal to 0.499 milliamps, so from this equation I can write what is VD. So VDD is equal to VDD is nothing but if you solve this equation, the maximum value of current voltage is 10, right? The maximum value of voltage is 10 here. So if I solve these two problems, that is if I add these two resistance, I will get 22k, and if I substitute 22k into the current is 0.499. This is 22k into 0.499. I will get the voltage that is greater than 10 volt. So it is not at all possible, right? Because the maximum voltage is 10 volt, so total resistance is 22k. If I substitute this ID, that is 0.499 milli, I will get the voltage that is greater than the 10 volt. So I am taking 0.4 milliamps is my ID value. So what is the IDQ value? IDQ is nothing but 0.4 milliamps. Okay, so I am going to substitute this ID in the second equation. If I substitute the second equation, I will get Vs is equal to minus 1.24 volt. So next, what I am going to do VDD is equal to IDRD plus V naught. You can see in the diagram what is VDD. VDD is equal to IDRD plus V naught. So we know that the ID value, RD value also I know, VDD value also I know. So if I solve, I will get V naught is equal to 0. Okay, so V naught is nothing but VD, right? V naught is nothing but VD, because at the drain only I am getting the output. So we know that the transistor must operate in the saturation region. So our saturation in the condition is VDS should be greater than VGS minus VT. So VDS I can write it as VD minus VS. VGS I can write it as VG minus VS. So VD is 0 and VS is minus 1.2 and VG also 0, that is 1.2. What is VT? VT is 0.8. So if I solve, I will get 1.2 is greater than 0.4. So it is operating in the saturation region, and we know that the VDSQ value is nothing but 1.2 volt. Okay, and IDSQ value I have already given 0.4 milliamps. So this is how you have to find the Q point for the given MOSFET. So I hope this video is useful for you. Thank you very much.